Okay, this is part two of a two-part video on uh, frequency and relative frequency graphs. And again, I will tell you, we have histograms, frequency polygons, or also we call them line charts, and ogives, ogive, which we also call cumulative frequency graph. So um, now look at the difference between this and the previous question. The only difference is that here we will use the relative frequencies. If you look at part one, we have used frequencies. And so what is a relative frequency? So let me show you. You have 20 data. So in this case, if you want the relative frequency, let's do them one by one. For one, what is the relative frequency of this? So you can say this relative frequency of anything is you divide that number by the total number and you get it as a percentage, as a decimal. So this would be 0.05, which is 5%, yeah. But you write it as a decimal. Then for 2, if you divide it by 20, you will get, so let me put, yeah, for 1 you get 0.05, and let's complete this. So how about, let me just erase this part here, and just add or extend this table here and put relative frequency. So for the 1, we saw it's 0.05. For the 2, if you do 2 over 20, you'll get 0.1. For 3, you'll get 0.15. For 5, you'll get 0.25. And for 4, 0.2. For 3, 3 over 20, it will be 0.15. For 2, it will be 0.1. Okay? And one nice fact about relative frequency you need to know, I mean it makes sense, because these numbers add up to 20. So this means that if we add their percentages, we must get 1 at the end. You try adding these numbers that you get, and you should obtain 1. If you don't obtain 1, then you know that you've done something wrong. So a question that could be asked also, like, let me hide this from you. If I hide it and tell you that this is a relative frequency table, find the missing value here. So I could ask you this question. Then you just know that they must add up to 1. So you would say that this question mark is just 1 minus the sum of the rest, 0.05 plus 0.1 plus 0.15 plus 0.2 plus 0.15 plus 0.1. If you subtract all of this from 1, you will get or recover your 0.25. Okay? So remember this important fact, because it will make you understand things better in the graphs. So now we will go to the next page, and on the next page we have a graph of the histogram and the frequency polygon together. And then on the page after that, we will look at the ogive. Okay, so let's go to the next page. Now, remember, if you watch part 1, things will make a lot of sense to you. Notice that I put the same table, frequency table, but I replaced the frequency with the relative frequency. Now, for us, what's important in this question is that they asked about relative frequency graphs. That's why we replaced the frequency by the relative frequency. And so all what you have to do now, it's nice also that here you see it tells you that they add up to 1, so it's good. And you do the exact same thing that we did in part 1, but just on the y-axis, look carefully, you have the relative frequency here. Okay, so you just put these rectangles. The first one goes up to 0.05. It's because of the relative frequency 0.05. Then the next one goes to 0.1. Okay, and then the other class goes to 0.15, and so on. And if you add up all these here, this plus this, I mean the heights, if you add up all the heights, this height plus this height plus this height plus this height, this height, this height, this height, all of them should give you exactly 1. Okay, and then you remember for the frequency polygon, you just put the relative frequencies here and the midpoints of each class. And in part 1 we looked at this and we did it just instead of relative frequency. If you remember, in part 1 it was just the frequency, there was no relative frequency. That's the only difference between the two questions. But it's a big difference. It's sometimes easier to read from here than to read from the one that has the frequency. We will see in the next one when we do the ogive. So look for the ogive. It's here. So how do you do the ogive? Look at part 1 and you will know how we compute the cumulative frequency from the frequency. Then just do the same thing that we did for getting relative frequency from frequency. Just get the percentage as a decimal. So 0, it's 0. 1 out of, the total values is 2, so it will be 0.05 or 5%. For 3, 0.15. But now remember, the cumulative frequency is getting larger and larger. So 6, it will be 0.3, 11, 0.55, 15, 18, and then at 20 you will reach 1, which is like 100%. And then you just do exactly what we did before. You do these dots. So for each class you put for less than, if you remember, we also talked about why we put less than for cumulative frequency. And just for each one of the class limits or boundaries, you'll put the dot that corresponds to its cumulative relative frequency, and then connect the dots. So let us try to understand this better. For example, what does this tell us exactly? This dot that I chose here. Let me put an X. So it when you go down, it's at 25.5, and when you go to this side on the y-axis, which has the cumulative relative frequency, you'll get the 0.05. Sorry, 0.55. I know this from here, okay? So for less than 25.5, I have 0.55. So that's why when I chose this 25.5, I knew that when I go up, I will get to 0.55. But what is it telling us? It's saying in terms of percentages. So you can get from this that the runners, this question was about runners, so let me write it better. So the runners who ran less than 25.5 miles are 55%. So 0.05, which is 55%. So you can, or, this is not a nice way of saying it. A better way of saying it is that 55% of runners, of the 20 runners, ran less than this number, the 25.5. And the 25.5 was the limit of this class. Okay? So when you compute its cumulative frequency, you'll add this, plus this, plus this, plus all of the ones before the 25.5. So up to here. Everything up to here, you add it. Okay? And this is how you get the cumulative frequency. And then when you get the cumulative relative frequency from the cumulative frequency, you do the ogive, which is very simple. Just put the dots and connect them with lines. And I will stop this video here.